Hi, so today I want to talk about graphing linear inequalities. So the first thing for us to understand is to have a small recap of the essential signs we use in inequalities. So the first sign would be the smaller than sign. Second sign would be the greater than sign. The smaller than or equal to sign, and the greater than or equal to sign. Now let's look at the structure of an inequality. Let's do a small recap. So in linear inequality, we have the left hand side, we have the sign, and we have the right hand side. So for example, a common inequality would probably be the left hand side would have y, and we have smaller than, and we have x. So this inequality represents the portion of the graph which includes the line y equals x. So this is the root equation of this inequality. Okay, the first important distinction that we should make is between the signs smaller than and greater than, and the signs smaller than or equal to and greater than or equal to. So this would obviously include the points on the line, and this would not include the points on the line. So when we draw the graphs using both these inequalities, when we see the or equal to, we have to include all the points on the line. So we draw a solid line for the graph. But when we don't see the or equal to sign, and we know that the points on the graph are not included in the inequality, then we have to draw a dotted line when we map the graph. Okay, so now let's go into our first example. We have the inequality y is smaller than x. The first thing you want to notice is just the smaller than. So we know that in the graph we have to use a dotted line. Use a dotted line. So the first step, I'm going to write the first step here, is to find the root equation. So the root equation is found by replacing the inequality sign with the equal sign. So here it's y is smaller than x. So we just replace the sign, the inequality with an equal sign. So the root equation will obviously be y equals x. Number 2, graph it. So now I want to graph y equals x. Okay, so now we have a visual idea of how this graph would look like. So the first thing we see, we realize that this was an ordinary inequality sign, so we used a dotted line graph. Okay, so we have drawn the graph. Now let's move to step 3. Now we have to decide which region A or region B, which region satisfies this inequality where the value of y is smaller than its corresponding value of x. So we have to do the inequality test. Okay, so I'm going to do the inequality test over here. So the first thing for an inequality test is to choose one point from each portion, from each region. So we have region A and region B, so we have to choose only one point. So from region A, I'm just going to choose any point. Can be any point in this part, in this half of the triangle here, any point. I'm going to choose a simple one, perhaps 1, 2. I'm going to choose the point 1, 2 from region A. From region B, I'm going to choose the point 2, 1. It can be any point. It's just for the sake of the test. Okay, now let's test the point in region A. So we have the point 1, 2. Okay, so now is the value of 2 smaller than 1? So substitute inside the inequality. Is 2 smaller than 1? No, so it's not region A, because all the points in region A have to satisfy this inequality. So we already know that it's not region A. So we have to test region B. Region B, it's going to be 2, 1. Okay, substitute inside the inequality. 1 is smaller than 2. Yes, 1 is smaller than 2. So we can decide that region B is the one that satisfies this inequality. So step 4 would be to shade. So after the inequality test, we've decided which portion satisfies the inequality, and we just shade that portion. Okay, we have clearly indicated which portion. Now let's move to a more complex inequality. X over 2 is greater than or equal to y. So the first thing we have to realize is this is an or equal to. which means that we have to draw the graph with a solid line. It has to be a solid line graph. So since this in this inequality, the value of y is not on the left hand side, to make it easier for us to visualize, the first step I would do is move the y to the left hand side. So that would be y is smaller than or equal to x over 2. Now let's write the characteristic or the root equation of this inequality. So the root equation would be y equals x over 2. Now let's map the graph. Okay, excuse the rough sketch. So this is the graph y equals x over 2. And this time notice I've used a solid line because we have the or equal to sign. So all the points on this graph are included in this inequality. So when we satisfy the inequality, all these points are included. So I've drawn a solid line here. So we've also drawn the graph. So now step 3, let's do our inequality test. So I'm going to choose 2 points from region A and region B. So from region A, I'm going to choose any point. Perhaps I'm going to choose 2, 3. Perhaps. And from region B, I'm going to choose 4, 1. So this is going to be 2, 3. And this is going to be 4, 1. Okay, then I'm going to do the test here. For region A, we have the point 2, 3. So substitute inside this inequality right here. So is 3 smaller than or equal to 2 over 2? Is 3 smaller than or equal to 1? Nope. So it can't be region A. Now let's try region B. It's going to be 4, 1. Is 1 smaller than or equal to 4 over 2? 1 is smaller than or equal to 2. Yes. So region B satisfies this inequality. So step 4 would be to shade the wanted region. So now we already know that region B is the region we want. So I'm going to shade it. Okay. So now we've understood the principles of graphing linear inequality. In the next video, we're going to be having a look at compound inequalities.